So this is the below grade waterproofing do's and don'ts checklist. Some of this will be relatively comical and some of it will be good at installation. One of the things that we always like to see and recommend is, we call it gridding off of a job site. So if you know that your deck that you're coating is 100,000 square feet, we like to see you gridding off the material on a job site. We do that for a specific reason. Because if you have one pail next to a guy and somebody just keeps bringing in pails, he's going to try and stretch the material as far as he can. If you grid off the job site, you know you put the pail every however many square feet. So if we're installing it at 60 mils, that's 25 square feet. I don't know the metric conversion for that offhand and I apologize, but every 25 square feet, you'll have a new pail on the job site. So that way you know that you have the correct mill thickness. Because you're not trying to stretch the material, you're not trying to put too much down at one period of time. The other thing is, we talked about in the presentation earlier, is we want to make sure that we clear off anything that could impede the bond or puncture the membrane. In this case, the nail could end up puncturing the membrane when it's applied. Especially if they put another slab on top of this, the force of the slab, the force of the insulation and protection, that sharp nail could put a hole in the membrane. We want to make sure that stuff's removed. That's a big don't. This is one of my very good coworkers back in Cleveland, Ohio. It's a big don't to have him installing material on your job site. But in all seriousness though, you can see that he is working the material. He should be pushing it as opposed to pulling it. As I also said, you can see that he has a pail next to him. There should be other pails around him, gridding off the job site to make sure so he's not trying to stretch material too far. You can see that they did the transitions already, now they're just doing the field of the membrane. Another thing that I like to see a lot in a membrane application is you have one guy squeegeeing he is going this way, and then you have another guy with spiked shoes on going the opposite way with a roller to make it flat, make it more uniform. Do you guys typically use spiked shoes down here? Does anybody not know what spiked shoes look like? Raise your hand if you don't know. Just grab it out of my bag. I brought a set of my brand new spiked shoes. I haven't used them yet, so I can show them. So if you're going to stand on the membrane before it's cured, you want to make sure to have these on your feet. The spikes go into the membrane as it's wet, and then the membrane seals around it, just like the squeegee. And then this is attached to your boot. So if you're going to be walking on the job site, putting the coating down the membrane, you want to make sure to use yourself a pair of these. Maybe I'll put them on tomorrow when we do the coatings demo, but I tend to trip. This is a great application of the membrane. They have the appropriate thickness down. It's extremely smooth. You can see because what they did was they squeegeed it one way and they back rolled it the other way to knock down any ridges that may have been in there. They have the transition on the upturn at the appropriate thickness. This is a very good application. And then they'll come in after it's cured up and put drainage and or protection, and then their topping right. Here is, we talked earlier about all these bug holes, the voids in the concrete. Remember I was saying that those needs to be patched and repaired before the application of the membrane? This is why. You end up creating these voids in there, and as the membrane gets hot before it cures, that void will expand. That air pocket will expand in there. So now they would have to come in and cut these and fix them after the fact. That's why it's good to make sure that your surface prep is done right the first time. We talked about protection briefly of the membranes. If you have a situation where you have your concrete rebar sitting right on top of the membrane, that's not necessarily a good thing, because then you have the potential to poke through the membrane and you don't have that monolithic, uniform, waterproofing membrane anymore. That's why we want to see a protection course, such as the protection board or the drainage mat on top of the membrane, so that way something doesn't puncture and poke through it. Here you can see this is not a great application. They left the membrane exposed way too long. It's dirty, it's got debris everywhere, there's no protection. This is just a pour all around application here. This is that same job. This is a little better, but it's not by much. We'll get to some other pictures from this job where it looks even worse. Here. This is one of the don'ts. All of this debris material, they don't have the connections done properly. They're not tying into everything else the way it should be, the way the standard details or even custom details would exemplify. All of these sharp objects sitting directly on the membrane can puncture it, rendering your waterproofing membrane useless. Protection needs to be taken to make sure you don't have that issue, making sure that that membrane is covered up with a protection mat or drainage, so you don't have those issues. Here's just the same picture, but it's a further back picture. You can see there's more debris. Again, it's been left out so long. They've got garbage laying on the site. Water sits there, could pond on it, which is not a huge deal. Depends on how long it's sitting there. But this job was actually abandoned, and then they had to come back to it because the owner wasn't paying their bills. So they just left it the way it was. That's why it looks so bad. What I forgot to mention in the other picture was there was no protection under the bricks. They were putting the membrane directly onto the bricks right onto the membrane. That is real hard to see over there, but on my computer it's a lot easier. The point that I'm trying to make out here is compatibility between this sealant or product to the existing urethane membrane or coating that's down there already. When you're installing these materials, you want to make sure that one product is compatible with the other. If you're using the same manufacturer for the whole system, it's a lot easier to ask, is this compatible with this? Because I can tell you what sealants are compatible with 250GC and what is not. If you have to use a different manufacturer's sealant, a different manufacturer's peel and stick and tying into our membrane, that's when things can get a little challenging, because we have to be on the same page to make sure that we validated the adhesion and compatibility between these membranes and situations here. So that's why we always use the expression in the United States, we want to provide the whole building solution for you, so you don't have to piecemeal the job together. That you can use our sealants, you can use our coatings, our waterproofing, our air barriers, whatever it may be, our roofing, because we know that we work together, we're compatible with everything. The expression that we use at home is, if something goes wrong, you only have one throat to choke. You're not trying to sort down different manufacturers. We use this picture in the presentation, but this is a great picture of an expansion joint going in. We have the backer rod sitting in the joint. We have the detail coat of the Tremproof 250GC on both sides of the joint. And then we have the elastomeric sheeting mechanically anchored with the paraterm bar, and then they're going to come over the rest of that with the membrane. This is by far and away the best expansion joint I've seen on a commercial job site with a waterproofing membrane. Remember we talked about Paraseal? We talked about making sure that there are no holes, no voids, so we can have that compaction that we require, which is 24 pounds per square foot. So whatever that translates to in metric. That is not acceptable, because you're not going to have that compaction required there. That would need to be cleaned out and then the block lowered or something filled in there. Something like a patch and repair or another piece of wood. Here's another installation where a situation where you're not going to have the appropriate amount of compaction for the paraseal membrane on your lagging wall. That's muy mal? Muy malo? Again, this is supposed to be grout. Grout would suffice to provide that rigid, if you have a gap between the wood lagging walls, the grout would suffice to be rigid to hold the membrane in place for the compaction required. But this is a good solution to that problem that they had. Here you can see this is a very old picture. Again, another one that's probably older than me. But I like this one in particular because it is an interior application. So this is a restoration job where they came in, they tore up the slab, they put down their 6 mil polyethylene sheeting, and then they came in after the fact, and now they're putting in their deck seal, which is the clear version of paraseal. Same mill thickness, same bent length concentration, just a clear HDPE versus a black HDPE. And you can see that they're taking great care, making sure that the seams are rolled tight, the upturns are done correctly. They have a turn bar mechanically fastened every 8 inches on center, and then they're going to come in and pour their concrete slab on top of that. This is just, like I said, a great opportunity for restoration, and I think you can see that here. This is a do not. The sheet is just mangled that they have there. I would advise them to just rip this detail section of the paraseal off the wall and just start over again, because that is not, there's the potential to have lots of leaks with all of these edges and the inappropriate folds there and whatnot. So, as we said at the beginning of the presentations, the devil is in the details with all of these waterproofing membranes. Making sure that care taken, installation is done correctly. Here's a good example of the super stop. We talked about making sure that in between your cold joints, concrete pour to concrete pour, that you have a flat, uniform surface. We looked at some of the pictures in the other presentation. You can see that this isn't mechanically fastened yet, but it will be. And it's set on a flat, uniform surface, as opposed to the other one that we saw that was all corrugated and rough and ugly. Does anybody remember why I said the termination bar is so important? So for those of you that can't quite make out what's going on here, there was a sheet applied waterproofing membrane there. Sorry I didn't dive so much into the paramastic. It's a termination mastic that you would use with the paraseal product. You could use it in, for the, if you put a turn bar right there, that would be a great application for it. You can use it in transitions and corners to give you that that angled bead, the cant bead that I was talking about earlier. You could use it to seal some of the stuff together on the inside too. So I apologize I didn't dive into it. I was trying to cover a bunch of different accessories. But yes, the Parastick and Dry Paramastic are also accessories in the Paraseal line that you can do all those different things that I just described. Okay. So I apologize for not including that in the presentation. But the issue in this picture is, as I said, there was a waterproofing membrane there. Now the waterproofing membrane is probably down a couple feet. So this is why the termination bar is so important. It looks like they just came in and haphazardly fastened the membrane to the wall. They didn't fasten it every 8 inches on center, used the sealant to terminate it properly. And when they poured the aggregate in there in this backfilled condition, it just tore it right off the wall. Here, it looks like it's a good application, but the issue that you have is we have these holes in here for a reason. The holes are your fastening pattern. So this way you know there's a hole, there should be a screw through it. So you don't have to make your own holes. And the requirement is that these are every 8 inches on center. So if that's outside of that, we know that it's greater than every 8 inches on center. But the bead of sealant at the top looks very nice. So at first when I saw this picture, I said, "What? This looks horrible." But now that I got a better, closer view of it, this is actually very good. Because what they have happen here is, this is a steel piling that they're using in a lagging wall. And this is a cement board that they're using to protect the paraseal membrane. So what they did is, they didn't want this giant steel structure coming up out of the ground. So they cut it off with welding tools. The welding tools give off sparks. If the sparks hit the membrane, it'll melt the membrane and create issues. That's why it's a great idea, if you're doing any welding around any of our membranes, to make sure to use temporary protection. Again, another situation where did the membrane go? This should be terminated at the top. Some people think that you can get away without doing it, and you probably can in some applications, but I don't want to be in an application where you have a situation like this, where you're missing a couple feet of membrane because you didn't terminate it at the top properly. We talked about the super stop, making sure to have a smooth substrate that you're pouring it on. You're putting it onto before the next concrete pour. The super stop should follow the contour of that smooth substrate. These ridges are not a good idea. That's not acceptable from my perspective. As a Tremco tech rep, I would take issue with that. I would want it to be smooth and flat. But the concrete is not exactly smooth and flat either, so that's the other part of the issue. Obviously, the concrete pour is not going to be perfect, and I get that. You're not going to have a steel trowel finish on the concrete at that pour, but you want it to be as flat as you can get it. And if you have, what you could do too is you could even come in, and if it's real bad, you could patch it and use a like one of the Vandex products or one of the Euclid products to come in and make that smooth again, and then put your super stop and mechanically anchor it then. That's what I would recommend to do. We talked about the lagging walls. The lagging walls hold the earth back, and if we're going to install the paraseal, we want to install it to a solid substrate. This is just chain link fence. There's no lagging wall. There's no steel pilings holding things in place. We showed up on this job site, and we're extremely concerned at the application that the contractor and sales rep wanted to use. This was in Canada years and years ago. But we ended up telling them that they had to install the steel pilings and having the wood lagging there to install our membrane. With that being said, that is all of the content that I have today.